Okay, momentum and impulse. This is a chapter that deals with mostly collisions. So, what is momentum? Definition is a property of all moving objects. So all moving objects have momentum as long as they have both mass and velocity. And the formula is simple. P equals mv. It's measured in kilogram meters per second. There is no special units for momentum. And it's a vector quantity, which means it has both magnitude and direction. And the direction is always the same as the velocity. So let's try a problem. What's the momentum of a 2,000 kilogram car traveling with a speed of 5 meters per second? Okay, P equals mv, 2,000 times 5, 10,000 kilogram meters per second. What would be its momentum if it was traveling at 10 meters per second? So we're doubling the velocity. What do you think happens to the momentum? Of course, we double the momentum. It's directly related to the velocity, directly related to the mass. So let's compare momentum. Which one of these things has more momentum? This 2,000 kilogram car at 5 meters per second, or 10,000 bus moving at 1 meter per second? Yeah, it's a trick question. They have the same momentum. They both have 10,000 kilogram meters per second of momentum. So smart. How about this soccer player moving at 2 meters per second versus the 60 kilogram ref who's at rest? Yep, the player has more momentum. He's got 60 kilogram meters per second while the ref has none. He has a red card which can stop the play, but that's about it. So impulse is the change in momentum. When we change an object's momentum, we change its motion. We either speed it up, slow it down, change its direction. And it's written this way. J equals delta P. Delta P is equal to m delta V, so we could substitute that and say, since A is equal to delta V over T, a little bit of algebraic mathematics gives us delta P equals MAT. So unlike work, which makes me mad, change in momentum makes me mat, I guess, MAT. And so MA is force, delta P is equal to force times T. And if you think about it, if I wanted to change an object's motion, the harder I push on it, or the longer I push on it, the greater the change in momentum. So let's try a dragster. Here we go. 60 kilogram drag racer accelerates from 0 to 330 miles per hour, which is 148 meters per second, in 5 seconds. What's the change in momentum encountered by the racer? Well, J equals m delta V. Since the final velocity was 148 and the initial was 0, 148 minus 0 gives us 148. So a total change in momentum of 8,880 kilogram meters per second, which is the impulse. What's the average force exerted? Well, we can do that working backwards from Ft, and we get 1776 newtons for 5 seconds. How many G's does he experience? Well, that's a comparison of the amount of force applied to the amount of force we normally would experience due to gravity. So the force due to gravity would, of course, be 588.6 newtons. Oh, gravity, your force on me is m times g. And, of course, comparing the force applied to the force of gravity, we get about 3 G's. How about this guy being shot out of a cannon? A 55 kilogram human cannonball flies into a waiting net, hits the net with an initial speed of 15 meters per second, and the net stops its motion in 5 seconds. What's the change in momentum encountered by this person? Yeah, it's negative 825 kilogram meters per second, because the change in velocity from V final 0 and V initial 15 is negative 15 meters per second. What's the average force exerted on the person during this deceleration? Again, J equals Ft, so it's negative 1650 meters. Again, it has to be pushing him in the direction opposite his motion to bring him to rest. How many G's is that? Well, roughly 3.1 G's when we compare them. So that's momentum and impulse, gang. See you in class.